Hi, Assalamualaikum warahmatullahi ta'ala wabarakatuh. So from our group, we will present you on the topic of moving average and exponential smoothing in forecasting. So this is our group member, Hisyam, myself, Faris, Syafiq, and Cass. So this is the topic online for our topic. We will talk about introduction to the forecasting, what is the moving average, understanding on the moving average, step by step, simple moving average, and so on until we post this video for this topic for our group. So here, what is in forecasting? Forecasting is the process of predicting future events based on past and present data. Is a critical tool in various fields from business and finance to weather prediction and inventory management. Accurate forecasting enables better decision making, resource allocation, and strategic planning. So, in terms of business planning, this forecasting is used to predict sales, revenue, and market trend. For inventory management, we use forecasting to optimizing stock level and to meet customer demand. And for operational efficiency is to scheduling the staff and managing our resources. So that is the forecasting. So forecasting actually is have a three type of forecasting. The first one is short range forecasting. Normally, generally less than 3 months. This short-range forecasting is to support daily operational planning like scheduling, workforce level, and inventory management. The second one is medium forecasting. Normally, it's between 3 months to 3 years. This to help sales planning, budgeting, and production scheduling. And the last one is long range forecasting. Is more to business for exit than 3 years is more focusing on strategic business, product development, and facility expansion. Okay. Next, why forecasting is matters? The first one because it's a critical role of forecasting. Forecasting provide essential estimate of future demand before actual data become available, guiding business decision. The second one, impact on the operation. The accuracy of forecast can influence supply chain, HR, and capacity planning to ensure that coordinated operational management. The third one, to reduce or minimize business risk. By doing the forecast, we help minimize inefficiencies, missed opportunities, and customer dissatisfaction by reducing uncertainty. The the last one, why forecasting matters is competitive advantage. Forecasting support strategic planning, resource allocation, and responsive, helping business maintain and helping the business to maintain the competitiveness in the market. So there is 7 steps on the forecasting. So the first one is to define the forecast purpose. This defined process is to establish the purpose of what we doing the forecast to guiding its application in operations like staffing and supply management. The second step is selecting forecast item. This to re, this to focus on relevant metrics like daily attendance to ensure that forecasting is aligned with operational needs. The third one, to determine time horizon by specify forecast duration from short-term to long-term projection, this enabling flexible planning. The fourth step is choosing forecast model. So different models like moving average and regression provide very perspective and forecast accuracy. The fifth step is data collection and analysis. The next one is generating the forecast, the step number 6. This generating the forecast, we compute the expected outcome based on the data, predicting actionable attendance. And the last one to validate and implementation of the forecasting. So then for the next one on quantitative and qualitative, I pass to my group members to explain on this to you all. Thank you, everyone.
Hi everyone, I'm Cassmir and I'll be continuing with the intro for forecasting. So on this slide, we will look at the forecasting approach, which falls into two broad categories, which is qualitative and quantitative. So for quantitative methods, it relies on mathematical model and historical data to predict future demand. So this includes techniques such as moving averages, exponential smoothing, trend projection, and regression analysis. So for qualitative method, on the other hand, this incorporates expert judgment, intuition, and experience. So these are useful when historical data is limited or when forecasting a new product. So in current practice, many organizations combine both approaches to achieve a more accurate and reliable forecast. So this hybrid forecasting approach leverages the strengths of data-driven model while incorporating insights from industry experts and market conditions. So next we'll take a look at the quantitative methods. We start with the first one, which is a naive approach. So naive approach assumes that the next period's demand equals the last period's. So this is a simple approach without any adjustments. For moving average, it smooths out short-term fluctuation by averaging demand data over a defined number of past periods. For exponential smoothing, it's the same as a moving average, but this technique assigns a greater weight to recent observation. So this is for better responsiveness and adaptive forecasting. For advanced trend methods like trend projection and linear projection, this utilizes historical trends and associative variables to improve the forecast accuracy. So next we'll look at the time series model, which is part of the quantitative method. So the basics of a time series forecasting is prediction based on past sequential data points at regular intervals to assume patterns persist into the future. So this is the basic of a time series model. So applications of a time series forecasting is used for sales forecasting, inventory planning, and financial analysis, which relies only on historical patterns alone. So the limitation of a time series model ignores external variables, so it may not predict sudden shift caused by external factors accurately. So the goal of a time series forecasting is to identify underlying structures in the data and project them forward to generate reliable forecasts for decision making in operations, marketing, and strategic planning. Next, we'll look at the uh, components of a time series model, which we have four components. The first one is a trend component, which shows a line in the long-term upward or downward momentum in the data over time. Next is seasonal variations, which have seasonal peaks and troughs, represent a recurring pattern that happen at a specific time each year. For cyclical movement, it reflects fluctuation related to economic or business cycles lasting multiple years. And lastly, random variations, which are irregular fluctuations caused by unforeseen events or noise in the data. So we can take a look at the example here. For trend, we have population growth affecting housing demand. And for seasonality, weekly restaurant peaks on Saturdays, where there is more customers coming. Okay, for cyclical movement, so economic boom and recession periods. So this sometimes lasts multiple years. And for random example for random variation is the sudden demand spike due to a viral trend. Okay, next we'll move on to moving average. I'll pass over to my friend. Thank you.
Okay, what is a moving average? So before we start, I'm Hisyam. So I will be explaining what is a moving average. So moving average is one of the forecasting method that we use to analyze time series data. So it works by calculating the average of a specific number of past data points, smoothing out short-term fluctuations, and highlighting longer-term trend or cycle. So basically, it is a continuously updated average of data that provides a clearer picture of the underlying trends. So to understand the moving average, we need to consider a sequence of data points over time. We select a window of data, let's say last 3 months of sale, and average them to get our forecast. This window then moves forward, incorporating the newest data point and dropping the oldest. So the key concept here is moving average smoothes out data to reveal trends, remove random fluctuation, and easily adaptable to new data. So for window size, we need to remember that a shorter window react faster to changes but is less smooth. And then a longer window is smoother but slower to react. So we move on to the step-by-step moving average. So determining the simple moving average. For moving average, we have two, which is simple moving average and the weighted moving average, which we will be explaining on the next slide. So for simple moving average, we need to choose the number of periods we noted by using the capital N for the moving average. This is to decide how many recent data points will be averaged. Okay, so next one is we select the group of n consecutive point that need to be averaged. Start at the nth observation and then take the last n value from the data set. Add the values in the group and then compute the total sum of the selected n values. We divide by n to get the simple moving average value. And then last is we move one data point forward and drop the oldest value and then repeat steps 2 to 4 until the end of the data. So this is the step-by-step weighted moving average. So first one, we need to choose the number of period of the weighted moving average. So this is to decide how many recent data point that will be averaged. For step 1 and step 2, we can see it is the same as the simple moving average. It starts to have different at step 3, which is we need to determine the corresponding weight, which is let's say we as an example, the most recent is 0.6 and then the next one is the 0.3 and then the oldest is 0.1, but the sum of weight must be equal to 1. This is the key point. And then higher weight given to more recent value. Okay, so pair each value with its weight. Let's say let's say we have most recent value, we must multiply it by its weight, and then next most recent we multiply its weight, and then etc. So step number 5, we multiply each value by its assigned weight, and then we need to compute the sum of all the weighted result, and that total is the weighted moving average for the n group. The last step will be we need to move one data point forward and drop the oldest value, and then repeat steps 2 until 5 until the end of the data. So if we see like this, it's quite hard to understand what we need to do. So on the next slide, my team member will show some example on how to solve the simple moving average and the weighted moving average.
So for the next, let us go through with a moving average example. So the sales of hair dryers at Walgreens store in Ohio over the 4 past months have been 100, 110, 120, and also 130 units, with 130 being the most recent sales. So it requires us to develop a moving average forecast for next month by using these three techniques: 3 month moving average, 4 month moving average, a weighted moving average, and also forecast if the next month's sales turn out to be 150 units. So to calculate 3 month moving average, we add all 3 months data and divide it by 3. So we will get 120 dryers. Similar to 4-month moving average, we will add the 4 months data and divide it by 4, whereby we will get 115 dry years. And for weighted moving average, we will multiply the forecast for each month by their respective weightage, whereby we will get 120 dry years. And to calculate the 4-month moving average, we just need to add all 4 months and divide it by 4. We will obtain the 125 dry years. So let's review on the advantages and disadvantages of moving average. The first advantage is simplicity. It is easy to understand and calculate. The second one is smoothing. It reduces noise in data and also highlight trends. And the third one is good for stable data. It is effective for data with consistent patterns. But it came with disadvantages whereby lacks actual trends, especially during rapid changes, and equal weighting. It treats all data points in the window equally, regardless of the recency. And also, it requires data, whereby it needs historical data to initiate the forecast. So what is exponential smoothing? Exponential smoothing is another popular forecasting technique. It assigns exponentially decreasing weight to older observations. More recent data points have a greater influence on the forecast than the older ones. It is more responsive to recent changes. Weighted average, where weights decreased exponentially over time, and more important to recent observations, only requires the previous forecast and the most recent actual value. So a smoothing constant alpha determines the weight given to the most recent observation. The alpha typically ranges from 0 to 1. The key concept is that it weighs recent data more heavily and also more responsive to change than a moving average. For smoothing constant, higher alpha closer to 1 forecast reacts strongly to recent changes, but for low alpha forecast is smoother and also less reactive.
Hi guys, my name is Faris. I will talk about the example of exponential smoothing. So over here we have the formula to calculate the new forecast, which is equal to previous forecast plus by the smoothing constant times the product of previous actual demand minus previous forecast. So for example, we have the data over here, previous forecast which is 142 units, previous actual demand, the units that we are selling, which is 153, and then alpha, which is 0.2, decided by our business organization. Keying into our formula, we are getting 144 units for our next forecast. So important notes over here: higher alpha means it will react faster to change, low alpha will make a smoother graph, and then a less responsive forecast. So what is the pros and cons of exponential smoothing? So it is simple and easy to use. Key into our formula and we are getting the new data for our next forecast. It requires low record keeping and minimal data, only recent actual value or data, and then the data of our previous forecast. It is more accurate than moving average. It will react to change more quickly than moving average lah. So what is the cons? So it only fit for a certain type of data, which are not suitable for data with strong trends or seasonality. Let's say for a business organization that's selling raya or festive apparel, and then it will require expertise because of alpha affect accuracy and requires trial and error to find a best alpha. So someone new that works on that certain department may use a wrong alpha, resulting in wrong forecast. So the same as the moving average, it will actually have a lag in actual values. So for summary, forecasting basically is a process of predicting a future event which can be used for business decision or our personal use. So both of them, moving average and exponential smoothing, are one of the time series model which use quantitative methods. So it will use data from our previous forecast and demand to calculate our next forecast. So the basis of this forecasting technique is by fitting a trend line to a series of historical data points. So basically we have data for, let's say, January and February. We use that data, make a straight line from that, and then extend it to, let's say, December to forecast for the next 10 months. So moving average and exponential smoothing use the same concept, except moving average use the average last n values, and exponential smoothing use the weighted average with alpha. Moving average is a simple and stable forecasting technique but have a slow reaction, while exponential smoothing, it is fast and recent expenses but still lacks of trend. Okay, so that's all from us. Thank you. And if you have any questions or any inquiry on moving averages and exponential smoothing, leave your comment below, and our team will provide you with the answer. Thanks.